Gentlemen, hi ladies and gentlemen, this is Mr. Green. This is another in my series of lessons on in Algebra 2. What we're going to be looking at today is we're going to look at a different way of looking at series and sequences. We're going to look at them in what's known as sigma notation. Now, I don't want anyone to get scared of this, but sigma notation simply represents the summing up of a sequence. So if we have a sequence 2, 5, 8, 11, 14, we want to take the sum of all those numbers. And the way we do that, by how do we add those up? Well, you can add them. 7 plus 8 is 15, plus 11 is 26, plus 14 is 40. And so you can add them up, and it's not a problem doing that. Okay? But what do you do if it gets to be a really big number? How do you represent that? How do you write out all those addition statements? It gets very cumbersome. Okay? And so in mathematics, we've got this way of writing them that we use this Greek symbol to write a sum. Okay? So the sum of the first n digits, s sub n, that's the sum of the first n digits, can be represented with this Greek symbol. And this Greek symbol right here is called a sigma. Okay? What does that stand for? It's a Greek letter in the alphabet, and it simply is the letter S. And so we're using the Greek letter S to represent the sum of some numbers. Now you can see right here, they've got this a sub 1. They're giving you a value right here, this a sub 1, or a sub I is what they're saying. And then they're saying from I is equal to 1 to n, and they're adding those all up. Okay? Maybe an example would work here. Down here, we've got this one here, and they want me to write this in its expanded form. So I starts at 1, so I'm going to say 6 times 1 plus, well, I'm going to go to 2. 6 plus 2, or times 2, excuse me, 6 times 2. I'm going to put these in parentheses so that we don't lose track of them. 6 times 1, 6 times 2, plus, I'm adding, that's what sigma means, 6 times 3 plus 6 times 4 parentheses. And that's where I'm going to stop. Why? Because the last number here is a 4. And so all I did was add those up. Well, 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And we are adding those numbers up like that. Okay? Let's see here. 30 and 30 is 60. So this would be equal to 60. Okay? You see how I added those up? But the whole point there was being able to write this in this sigma notation. I'm replacing the I with with the numbers 1 through 4. Okay? Maybe another example will help. Here we've got a sigma notation. It says the sum, and you see how I read that, the sum of k equaling 1 to 6 of k squared. So that's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Can we add those up? Well, I'm going to just kind of do a little regrouping here. That's 40, and that's 10 more. That's 50. And let's see here. That's 60, 70, 80, 90, 191. I'm sorry. 91? Is that right? Let's see here. 6, 11, 17, 27, 28, 29, 30, 31, carry 3, 6, 7, 8, 9. Yep, 91. That would be my answer there. Okay, let's try it one more time with this one over here. We've got 2n minus 1. N is going to go from 2 to 6. Does it have to start at 0? Does it have to start at 1? No, it can start anywhere at all. Okay? So let's start at 2n. So let's see here. 2 times 2 minus 1 plus 2 times 3 minus 1 plus 2 times 4 minus 1 plus, come down here, 2 times 5 minus 1 plus 2 times 6 minus 1. You can see how I just wrote out each one of the different terms. So this one is 4 minus 1. That's 3. 3 plus, and then 6 minus 1 is a 5. And 8 minus 1 is a 7. And 10 minus 1 is a 9. And 12 minus 1 is 11. And you add those all up, you get 2735. Hopefully I added that right in my head. Cool? Okay, let's do just a couple more, see if we can't figure them out here. Okay, this one says to write each series using sigma notation. So they want me to write it in sigma notation. So that means I'm going to need a sigma sign here. I know that. Okay? Let's see here. What I'm seeing is if I take 5 times I and subtract 1 from it, and I start I at I equaling 1 and going up to, let's see, this would be 1, 2, 3, 4, 5, 6, 7 to 7. I would get each one of these terms because, let's see here, 1 times 5 is 5 minus 1 is a 4. So put a 2 in there. 5 times 2 is 10 minus 1 is a 9. Put a 7 in there. 35 minus 1 is a 34. I get each one of those terms. This would be how I would write this in sigma notation. Okay? How about this one down here? Yeah, we can do fractions too. Sigma. Okay? Let's see here. We could say 1 over 2 to the ith power, where I equals 0 to 3. Okay? What does that mean? Well, if I put a 0 in there, 2 to the 0th is 1. 1 over 1 is a 1. I put a 1 in there, 2 to the 1 is a 2, so that's 1/2. I put a 2 in there, 2 squared is a 4, that's 1/4. Put a 3 in there, 2 to the 3rd is 8. So yes, that would work. You notice how I checked every one of them just to make certain I was getting them correct. When you're putting these together, this is difficult to do sometimes. It takes a little bit of ingenuity to come up with how you're going to come up with them. Let me tell you what I did in this one up here. I looked at this and I said, there's a difference in 5 in each one of these different terms here, right? Difference of 5 here. But it starts with the number 4. So I started off by putting a 1 in there and said, well, 5 minus 1 is a 4. And that's how I came up with this formula. It was a little bit of, it might look like a little bit of hocus pocus, but what I'm doing is I'm taking I times 5 to find each one of the terms and subtracting 1 to get the terms that they have on their list. Down here, I happened to notice that I had 1/2, 1/4, 1/8, and I could see how to do these really easily. This one I had to think about a little bit, and that's when I remembered that anything raised to the 0th power is 1. That's how I got 1 over 1. So that's why I started at 0 instead of starting at 1. So, no specific rules here. You got to come up with the formula on your own. You have to come up with the, where to start on your own. But you can do it different ways at different times and see what you come up with. Experiment with it. Play with it. See what you come up with as far as equations go. Enjoy it. If you have any problems, let me know. This is a difficult concept. So we're going to spend a couple of days looking at these different types of sigma notation. Okay? Talk to you later.